Okay, I'm going to go through the 2.2 quick check answers for AP. Okay, the first let's say here that it says you have an integrated rate law. The decomposition of nitrogen dioxide at a high temperature, there's the reaction, is a second order reaction. That's the key piece with respect to that reactant. The rate constant for this reaction is 3.4 liters per mole per minute. Okay, which is the same thing as saying molarity to the -1, minutes to the -1. Determine the time needed for the concentration to decrease from 2 moles per liter to 1.5 moles per liter. Well, the fact that, on the AP test, you are given some formulas, and this information down here. So not only given formulas, but you're given actually the value, what the different constants mean. So that's really nice in case you look at the equation and go, I don't remember what those mean. Okay, so this guy here, you might recognize this is the first order integrated rate law, and this one is the second order. Now they don't tell you which one is which, so you have to remember that. And you can kind of remember back to the graph. So when you're seeing, natural logs, you remember that's the first order. If you're seeing 1 over the concentration, that's second order. And this little guy here, this is the special case of half-life for a first order reaction. So you can go back and forth from half-life, and this tells you that that's the symbol for half-life. K gives you half-life, and half-life gives you K. We don't need that right now. So what we need is this second order equation. So you can see what we're going to have. We have 4 variables. So we need to know what is the concentration of A at time t, what is the concentration of A at time 0, our initial concentration, what is K, and what is T. So those are our 4 variables. So just look at our problem here. So we tell here the rate constant is 3.4. So this is K. So we have that value. And we want to go from 2.0 moles per liter to 1.5 moles per liter. So that means this must be our concentration at time 0, and this is our concentration at time t. And what we're looking for is we're looking for the time, so we're looking for t. So at this point it just becomes an algebra problem, kind of a semi-complex algebra problem, but we can certainly do it. So let's see if we can set this up. So 1 over, let's see what that was, 1.5, and that's moles per liter. Now I'm not going to worry about my units right now because it's going to get more confusing, but my constant is in moles per liter per minute, and my concentration are all moles per liter, so I know that's all going to be okay, and my time's going to come out to be minutes. So I say 1 over 1.5 minus 1 over 2.0, okay, equals 3.40, that's my constant, times t. Now I do a little bit of work here. 1 over 1.5, that's going to be 0.666666 repeating, minus 1 over 2, which is 0.5. I shouldn't have wrote that, okay. 0.5. Okay, so I know that that is going to come out to be 0.16666 repeating equals 3.4 times t. Okay, so therefore t is equal to 0.166 divided by 3.4, and that comes out to be 0.0490, and I know that's minutes. So kind of messy, but it's just an algebra problem substituting into this equation. There are 4 variables, 3 of them are given in the problem, and just work it out. Okay, the second part. The integrated rate law of hydrogen peroxide, okay, the catalyzed decomposition of hydrogen peroxide is studied and found to be first order. So again, that's important, first order. So during the analysis of the data, the graph to the right was produced. Okay, so here we have a straight line graph, and we have to say, okay, first order, what gives us a straight line graph? And that's when we do the ln of the concentration. So this is going to be the ln of H2O2. That is our vertical axis, and the bottom is time. Okay, on the graph, draw the line that represents the plot of the uncatalyzed first order decomposition. Well, when this was actually on the AP exam, this question really kind of confused people across the nation because they said, well, we've never done, any kind of graphing of catalyzed and uncatalyzed, but it's really not that kind of a question. It's not, you have seen this. You just think about it for a second. If it's uncatalyzed, what's that mean? It means you're going to do the same reaction, it's just going to take longer. So instead of taking this amount of time, it's going to take more time. So you just start from the same place and you end in the same place. It just takes a longer time. So all you need to do is draw some kind of a line, nice straight line, but it has a less slope. And that's the answer. Okay, for the third part, here we look at these graphs, and okay, we've seen these kind of graphs before, so even before we get into the question, we should say, okay, here's a straight line graph, and here's a curve, and here's a curve. So we know straight line graphs tell us something about the order of a reaction. So if this is concentration versus time, okay, if we get a straight line graph, we know that this is zero order. Now, if the 1 over concentration versus time had been a straight line, then we would know it's second order. And if it was ln of concentration versus time, we know it would have been first order, but those are not straight lines. So that data is not from a second order or first order reaction. So it's coming from a zero order. So now let's get to the question. Given the reaction is 0, 1, or 2, use the information in the graphs to respond to the following. Determine the order of the reaction with respect to ethanol. Well, we've done that. We know that's a zero order. Okay, we justify what's our thinking because the graph of concentration versus time is a straight line. I'm going to say it's linear. Well, straight line. Now, that is, just what my thinking is. We could also say, well, because the rate at which the concentration is used up, or rate at which the chemical is used up, is constant. It does not depend on the concentration of the ethanol. That would be a little more sophisticated answer, but really we're just kind of defining what zero order means. Okay, the second part on here says write the rate law for the reaction. So this isn't really not complex. It just says, okay, this is a zero order reaction. So what does that mean? That means rate equals K times the concentration of the ethanol to the 0 power. And what that really means is that rate equals K. Okay, because ethanol, anything to the 0 order is just 1, anything to the 0 power just 1, so rate equals a constant. So now we get to the last part here, determine the rate constant for the reaction. Well, the rate constant is just the rate. So all we have to do is rate, it gives us our rate constant. So we have to go back and look at our equation, look up our data. Can we figure out the rate of this? And yeah, the rate is definitely related to the slope. Okay, so the slope of this line is going to be the rate at which the ethanol disappears, and the rate of the reaction would be the negative of that. So all we have to do is find the negative of the slope of that line. So we can say, okay, I'm going to take this point and figure out the slope. So let's go back and do that. So the slope of the line, okay, rate's going to equal to the negative of the slope. Okay, and the slope of that line is, okay, if I'm back here, it looks like 0.002 minus 0.01. Okay, and so I'm just taking that's my rise, divided by run. I'm ending at 2,000, started at 0, so 2,000 minus 0. So that's that's going to be in time seconds. So this is going to be molarity. That's the difference in molarity over seconds. And if I calculate this, I'm going to get 0.008 over 2,000, which is going to be 4 times 10 to the negative 6th molarity per second. And again, this was a negative. The slope was negative, but I made the negative of that, so this can be positive. So my answer is 4 times 10 to the minus 6 moles per liter per second. And I hope I didn't mess you up on the signs. Okay, this is downhill, so it has a negative slope. The rate is positive. So I just want the positive answer here. And that's my rate. That's the value of K, because it's equal to the rate. And that is the quick check.